Okay, we will be presenting our group project, which is the designation of third order bandpass active filter circuit. Okay, my name is Muhammad Raihan bin Muhammad Azmi, metric number AE200105, and other group members are Muhammad Khairul Hafiz and Zulfikri Razali. Okay, so what is a filter? Filter is a device that permits the transmission of specific frequency. Okay, so its purpose is to diminish unwanted frequency noise caused by background noise or maybe a nonlinear characteristic exhibited by certain electronic device. So there are four primary types of filter: low pass, high pass, band pass, and band stop filter, band reject, which is band stop filter. So passive filter solely employ passive element like resistor, capacitor, and inductor, while active filter include the passive component and the active elements such as transistor and op-amp. Okay, so a simple active band pass filter can be constructed by combining a low pass and a high pass filter in cascade. Okay, so the importance to current technology trend. Okay, active filters are of great importance in electronic system, particularly in the context of current technology trends. They play a crucial role in ensuring efficient signal processing, precise frequency control, and also effective noise reduction. Active filters offer several advantages over passive filters, such as zero insertion loss, ability to design for desired pass band gain, interstate isolation, and the use of smaller components. As we can see the example here, active filters in biomedical context is to enhance the quality and reliability of ECG signal, while this example is the active filters in 5G technology context is to ensure the accurate reception and efficient signal processing. The next part is theory regarding the circuit being designed. Okay, the theory behind the circuit being designed is focused on creating a third order active band pass filter. The band pass filter allow a specific range of frequency known as the passband to pass through while attenuating frequency outside the range. So the circuit involves cascading a low pass filter and a high pass filter to create the band pass response. The term third order refers to the circuit roll-off rate, which we can see in the picture here, in general block diagram of the higher order filter. In third order filter, the roll-off rate, which is 18 dB per octave or 60 dB per decade. So the design incorporate multiple filtering stages using op-amp and passive components such as resistor and capacitor. So each stage contributes to the shaping the overall filter response, providing precise control over the desired frequency range and filter characteristic. That's all for my part. Thank you.
Hi, Assalamualaikum. My name is Muhammad Zulfikri Razali, matrix number DE210036. So I will explain about calculation third order band pass filter. So the given mid gain A is 70, low cut-off frequency 3 kHz, and high cut-off frequency 20 kHz. So the low pass filter high frequency 20 kHz. So we assume C capacitor 110 nanofarad, and we use the formula 1 over 2 pi multiply frequency multiply with capacitor. So we got a resistor 72.3 ohm. Alright, so for the high pass filter, assume C, okay, and we got 482.3 ohm. So the total gain is, we use the formula A total equal to A1 multiply A2 multiply A3 and A4. So we got A3 is 4.1833. So the RF that we got 700 multiplied by 3.1833, and we got 2.2 kilo ohms. And the mid gain that we got is 99.99, which is 70 for mid gain. Alright, So the gain is 70. So we use we use the gain that given to get dB. Okay, so we use the formula 20 log multiplied by gain 70. So we got 36.90 dB. All right. So the bandwidth is 30k minus 3 kilohertz. So we got 17 kilohertz. And the center frequency FO, we got 7745.97 hertz. And quality factor FO, center frequency divided by bandwidth. So we got 0.4556. Alright, so the component listed. Alright, so we go first about high pass filter. So the high pass filter, the operational amplifier of M we have used 4, which is 2 high pass filter and 2 OM low pass filter. Okay, so we don't use non-inverting amplifier. Alright, so we just only have 4 OM only. And the resistor we use 14 and capacitor we use 6 only. Alright, so we go first to the high pass filter. So high pass filter, we arrange the circuit with OM. That first one is 2 pole and second one is first single pole. So the 2 pole we use R1 482.3 based on the calculation given. Alright, so R2 we use same 482.3 ohm, and capacitor for both is 110 nanofarad. And R3 and R4, which is RA1 or RF, we use 1 kilo ohm. Alright, so that is the 2 pole. Alright, so the single pole we use R6, which is 482.3, and capacitor number 3 is 110 nanofarad. And for feedback resistor and RA, we use 700 ohm and 2.2 kilo ohm because the low cut-off frequency is 3 kilohertz. Alright, so for the low pass filter, we use the 2 pole R5 and R9 72.3 ohm, and capacitor 4 and capacitor 5, which is 2 pole for low pass filter, we use 110 nanofarad, and RA3 and RF use 1 kilo ohm, and single pole R10 72.3, capacitor 6 we use 110 nanofarad, and the high cut-off frequency is 20 kilohertz. Alright, so for the circuit diagram, okay, can we look the diagram? We use the Proteus software. So we this is the circuit diagram of our third order band pass filter, so that we know that we use only 4 ohm only because we don't have use non-inverting amplifier. So this is the hardware connection. Alright, on the breadboard. So we jump the ground at the 1 pole, and we jump the supply. We use the battery based on circuit diagram. So we jump the pin in the amplifier. So we got this hardware connection.
Hello, Assalamualaikum. My name is Muhammad Karafis bin Rahman. Number matrix CE200160. I'm for ECAD from group 7. Today I want to talk to you about the slide presentation for our group. For my part, for the simulation, the output from the frequency response graph from the Proteus software that we use. Okay, as you can see, this is the simulation we get. As you can see, this is the bandwidth, so only the height cutoff, frequency height, and we low cutoff. So next, okay, as you can see, the dB that is in simulation we got is 36.9 dB, which is our mid gain is 70. Okay, for the FL, frequency low is 30 at at 3 kHz, while the frequency height is 20 kHz. At the dB minus 3 dB, which is 33.9 dB. Okay, this is the picture of the results of the hardware simulation in the lab. Okay, for the analysis and discussion, as I can analyze, we use a third order bandpass filter with the low cutoff at 3 kHz, high cutoff at 20 kHz, and our mid gain of 70 dB. In case for the third order filter, the Singapore of filter stage is the first, which is the first circuit at the op-amp. That it makes sense to move the first order stage at the end of the circuit to reduce the filter noise. Okay, and a third order bandpass filter is a type of electronic filter that is designed to pass a specific range of frequencies, known as a bandpass band, while rejecting the frequency of outside of this range, which is known as the stop bands. Okay, the VCC supply is not plus minus 15 volt due to any wrong connection to oscilloscope and function generator, or maybe due to wrong connection somewhere in circuit, even though we have checked in multiple times. Under that, the V input in the process is not same as we do in our lab because the V input is clipping. So maybe because of the component or connection we can figure out, but all the IC working just fine and we got the result. Okay, this is a graph of active bandpass that we recorded in the laboratory. As you can see, at the 500 Hz, we got the dB 33 point something, negative 0.31 dB. So our low cutoff is at 3 kHz, which negative 26.8, which is same at our high cutoff is 20, which is negative 26.8. So as you can see, the graph is same like always like the bandwidth. Okay, for the conclusion, we are designing the third order bandpass filter using the operational amplifier, which is op-amp, using the op-amp. Okay, we can analyze the function of each stage in the third order bandpass filter, as mentioned in the discussion analysis. Okay, we can discover how to create a third bandpass order filter by combining a order low pass and high pass filter. The result however by using digital oscilloscope is in the laboratory, which is important to us to get the result. Okay, that's all from me. Thank you.